instructions to you are to factor. I want you to just factor this one, please.
Okay. I'm sending you the picture of
Oh, good. Good.
the review worksheet. Okay, should have just sent.
Okay. I'll take a look at that and I'll incorporate that into our lesson here today.
Okay.
But as soon as you're ready, I want you to try factoring this one here. If you have questions, please let me know.
Okay.
Any questions on this one?
No, I think I got an answer. So you said factoring, right?
Yeah, this is a factor problem.
I got 2x squared minus 1 times 3x minus 7.
Like this?
Yeah.
Okay, so one way we can check, and we'll do it here because it does look like your teacher might ask you something like this, and I will do it for you, is we're gonna FOIL this or simplify this. Okay.
Okay.
So it's the first times the first, that's 6x cubed. That's looking pretty good. Then minus 14x squared, that's the O. Minus 3x, that's the I, looking really good. Minus 1 times minus 1 is positive 7. So yes, that is correct.
Okay.
All right, now when I look at your review sheet, some questions for you. This is to better help you. Does your teacher ask you, do you know from past reviews, are the questions ever just pulled directly from this? Like if we do some of these, will they potentially be copied, will they be on the exam?
I don't think so, but I don't really know. I haven't
Okay.
really seen any questions straight from here.
Okay, no, well, so I'm talking about like past exams, like when you had your exam on systems of equations and you got your review, was the exam, like, do you ever remember seeing, oh yeah, I already saw that because it's exactly from the review?
No, I do not remember that.
Okay. Next question is the exam structured like this, where there's going to be a simplify section, a factor each polynomial section, and a solve by factoring section? Does it usually follow that structure?
Maybe. So
Okay.
usually it goes in order by lesson or like what they taught us,
Yes.
like in order.
Okay. Got it. Last, I think this will be the last question. Do you ever have like this vocabulary at the top? Do they are those thrown in? Do you get like vocabulary questions? What does that usually look like on the test?
No, usually there's no vocab on the test.
So it's purely solving,
Yeah,
free
usually
response or multiple choice?
free response.
Free response. Okay. All right. That's enough for me. Let's look at a problem like 3.
Okay.
And I'd like you to tell me how to solve this. One of the best ways I can judge whether you understand it is to tell me back how to do something.
Do I multiply it out?
So give me more. Yes, but give me more words. What are you going to multiply first?
5y squared times y.
Okay. And what are you going to multiply second?
5y squared times -4.
Okay. And how about third?
3y times y, or -3y times y.
Okay, good. And next?
-3y times -4.
Good. And then what's your next one?
-6 times y,
Okay.
and then -6 times -4.
Okay. Now, do you like to show that or do you show the result? Like do you write 5y cubed here, or do you write 5y squared times y when you do it?
I usually write 5y cubed when I draw like a little arrow.
Good, good.
Yeah.
Okay. Minus 20y squared. All right. Now, when you multiply minus 3y times y, that's minus 3y squared. Do you ever put it underneath the term that has the same
Yeah, so
squares?
usually I'll just write the terms like going straight down. So I'll write 5y cubed,
So
and then
do you,
I'll put negative 20y directly under um the 5y cubed, and then I group them, and then
so you put this, do you put it here?
yeah, and then I'll put the 3y squared under that.
Okay. So let me show you an alternative approach, because this should have been shown in class. This is called the waterfall method, and
Okay.
you may like it. So um, now I'm going to take that minus 3y and multiply it by the positive 4. So that's plus 12y. Okay. And now I'm going to take the minus 6 and multiply it by the y. That's minus 6y. Minus 6 times minus 4 is positive 24. And the idea, Arizona, you maybe don't see them very often, but it's kind of like a waterfall. Okay. And the reason you do this is it's a lot easier to add things up when they are already in the like term category. So it's a lot easier to add minus 20y squared and minus 3y squared like this.
Okay.
So I mean, if I had shown you from the beginning, I would have said, you must do it like this. Question for you. Is it okay? Let's just say I was a student and I switched it up. I said, I'm going to do y minus 4 times 5y squared minus 3y minus 6. Will this give me the same result?
Um, it should, right? Because
You, you,
flipping it around,
you seem uncertain. So let me give you a numerical example. What is 4 times 5?
20,
What is 5 times 4?
20.
Does the order matter when you multiply?
No.
Are you multiplying here?
Yes.
So the order does not matter. Yes, you get the same result.
Okay.
So why do I bring that up? Well, let's look at number 4. Do you think the order matters in which you multiply these?
Probably not.
Does not, it does not, yeah. So you have to choose. You have to say, like, I want to multiply the first two, the second two, the first and the third. Like one maybe jumps out at you. I don't know. I would
Oh,
probably, sorry, go ahead.
do I for this one, would I multiply like the first or whichever two I choose, so like the 2x plus
Yeah,
5 and the 3x minus 2, and then
yes.
factor that out and then multiply it by negative 5x minus 6?
So just maybe I'm slightly critical of your words here. You're multiplying these out. Factoring is when you is what you're doing in 13 through 21.
Okay.
So you're just multiplying. You're no factoring.
Oh, and then I
Yeah.
just multiply it again by
Yes. So
the last one.
I'd like you to FOIL this or multiply this for me, please.
Okay.
And let me know your final answer whenever you got it.
Okay. 3x minus 2, negative 5x minus 6. 6x squared minus 4x plus 15x minus 10. 6x squared plus 11x minus 10. Multiply that by negative 5x minus 6. It's negative 30x cubed.
Okay, so here you keep going, and that's fine. Just confirm your answer with mine here at the top. But yeah, keep going. I would encourage you to try this waterfall approach. I know it's pretty late in the game, so you don't have to, but uh, you know, I'll give you some helpful tips in the future lessons. But yeah, go ahead and work this out. Let me know what you come up with when you're all done.
Okay. So I got negative 30x cubed minus 91x squared minus 16x plus 60.
Yeah, completely correct.
Okay.
All right, good. Okay, so we've kind of covered, there's one more example I want to cover before we move on to some other stuff. Can you tell me in words what you would do to multiply either 6 or 9? And you can pick whichever one you want, but I just want you to tell me what you would
Oh,
do.
so because I don't really like dealing with squares, I would put it as 4p minus 3 times 4p minus 3, and then just FOIL it.
Okay, very good. Yeah, that's exactly right. All right. Okay, so let's go to 13 through 21, and none of these, well, so well, yeah, I mean, okay, let's look at 13 first. We're not going to go through all of these. We'd never have time to do all that. But when I look at 13, the instructions say to factor. What's the very first type of factoring you're only supposed to do?
Greatest common factor.
Greatest common factor. Now, one of the things you might notice here is the cube. The cube's a pretty good indicator. If you see a cube or power of 4, it's a pretty good indicator of greatest common factor or factor by grouping.
Okay.
So this one has both a letter and a number. Can you tell me what the greatest common factor is for this one?
7a.
7a. Now, if you don't do both, you make the work a lot harder for yourself. And I would assume your teacher's the type that they will do that. Like if you only bring the a out and you're looking at a times 7a squared plus 4a minus 5, and then you sit there and you multiply 7 times minus 5, you're making it a lot harder than you need to. Sorry,
Yeah.
this is sorry, 28a and 35. So again, that GCF is really key here. What does this FOIL to? Or I'm sorry, what does this factor to? Wrong word. What does this factor to here?
A squared plus. Oh wait, hang on. -5. So what adds to -5? That's 4 away.
So I like your words, but you got to be careful here. The way when I was doing the 4 away thing, I was making them both same sign.
Yep.
And it is 1 and 5, they're 4 away, but one has to be positive and one has to be negative.
Oh, it's -5 and 1.
Yeah. Well, -5 and 1 gives you +4.
Yeah.
So you want the other one. You want the one that, I'm sorry, -5 and 1 gives you
Oh,
-4.
oh
Sorry.
yeah. So I want
Sorry.
-1 and 5.
Right. So that when you say 4 away, which really does work, you keep them both positive and then you deal with the sign later.
Okay.
Okay, what goes in parentheses now that you know that this is the right pair? I'm surprised you're unsure here. It's a and a because of the a squared, and then it's
oh yeah, a minus 1
1.
and
Yeah,
then a
good.
plus 5.
Yeah. Okay. Okay, good. All right, let's do one more like that. I guess we can't. Let me have you try 17 really fast here.
Okay.
Try this one on your own, please.
Plus 7x minus 30. There's no GCF. And then, so it's 30. Make the tree thingy. What multiplies to 30, but it's 7 away.
So that you could just go through the list here.
Yep. Oh, 3 and 10.
Right. Now, the 7 away is good, but now you really are, it's really supposed to be minus 30. So that means 1 is negative and 1 is positive.
Yeah.
I really should have left room in there. But once you realize it's 3 and 10, you got to decide, is it
it's got to be -3 because that it has to add
yes,
to 7.
yes. So what goes in the parentheses here?
So x squared plus 10 and then negative 30 minus. Wait, no. Oh no, I had it negative 30 minus 3.
Like
Yeah.
this?
Yeah.
Okay, let's go back and look at our previous answer here. Do you see how it had a letter and a number, a letter and a number?
Oh, it's supposed to be x
Yeah, so
plus 10.
yes. X minus 3.
Yeah.
So these you've got to be really solid at, because like these are the fundamental ones. Maybe just you haven't done that many in a while, or it's been a while since you've done them. Let me have you try one more here. So just looking for one real quick. Let's go x squared minus 3x minus 70. I want you to try factoring this, please.
Okay, so it's negative 70. And that's to add up to negative 3, so it's going to be negative 10 and 7.
Okay, so
And
I agree.
x
Go ahead.
minus 10. Yeah, x minus 10 and then x plus 7.
Good, very good. Okay. All right, I feel better about what we were just doing now. All right, so the next problem I want us to look at is one like 18.
Okay.
And we will do 15. Try and get as much coverage as we can here. All right, so does this have a GCF?
No.
Does not. And it's not a perfect square trinomial. And the reason you know that is the square root of 12 is not nice.
Yeah.
And same thing with the square root of 15. Okay. In fact, I actually don't see any. Well, take that back. There's one. So what do you do? What do you do when it's not this? It's not one in front. What do you do to get this to be factorable?
Do
We
you
were working on this
multiply
the other.
12 by 15?
Yes,
Yeah.
exactly. And this is, I think you like saying the diamond
Yeah.
approach, which is fine.
And negative 28, so it has to add to negative 28, but multiply to be
180.
Yeah.
Okay, now you said you're allowed to use a calculator. Is that still true?
Yes.
Okay, so again, like you can use the whole 28 apart thing if you want. They are both negative, but you can try that method as well.
Okay.
Totally up to you. I would grab a calculator and start dividing, seeing what goes into there, into 180. Start with, I don't know, 5. Like what 5 and what goes into 180.
It's not 5, so I think it's 6.
Okay, so 6 and 30.
Oh
They
no, those are
are
24 apart.
right. And so 5 and 180, what is that? Is that better or worse? Yeah, so you grab your calculator, 180 divided by 5.
That gets 30. That gets 36. So then.
So that's 31 apart.
Yeah.
So the problem here is that this approach I'm telling you it doesn't work for everything. So you're gonna have to keep going here. Like 10 and 18. Now at first glance, what do you think of these? They're not 28 apart.
If you make them negative, they are.
Well, yeah, well, not, but see, this works. This is what you want. So it was kind of works most of the time.
Yeah.
Nothing in math works for every problem all the time.
Okay.
So once you get that, you can then break it apart. Now, do you want to go minus 18x, minus 10x, or which order do you like better?
Minus 18, minus 10.
Okay, so 12x squared minus 18x minus 10x plus 5, 15. I want you to
solve it.
Yes, please. Or not solve, you're just factoring. Solving's coming up.
6x 2x minus 3 2x minus 3, and then multiply by -5. Yep. 6x minus 5 times 2x minus 3. 6x minus 5 times 2x minus 3.
Like this.
Yep.
Okay, so you actually can FOIL to make sure if you have the time. 12x squared minus 18x minus 10x positive 15. Yeah, perfect. Okay, really good. All right, so let's look at 15 next. 15 is difference of squares.
Okay.
But it's it's more symbolic maybe than you're used to. So here we go. I think I recommended this the other night. You really want to figure out what it is that's squared that gets you back to the previous minus what is it squared that gets back you to the previous.
3b and then squared. I think you have to have
Yep.
the squared there.
Yep, that's right.
And then a 5a.
Yes. I'm just curious, do you normally look at the right number first or right term first?
No, usually I look at the left,
Okay.
but 9 is for some reason easier to
You were just drawn
get
to,
the
yeah,
square root for.
good.
Yeah.
So this is your big A minus your big B squared. And you do need to know this formula. It's A minus B times A plus B. So the key is really figuring out what goes in parentheses. You know, what is it that you're squaring to get back to the previous term? Because then you just use the formula here for that. So give me your final answer here, please.
So 5a minus 3b squared times 5a plus 3b squared.
Yes. Now, do you normally have enough time on the test to check your answers, or is it pretty rushed?
It depends on how big the test is and how well I understand the material.
Okay. So, you know, you can FOIL these to check.
Yep.
Yeah, but I would not do that until you've gone through like the entire test. I wouldn't check until I've done everything. And
Yep.
and I would only tell you to mark the ones that you're uncertain about, like as a starting point.
Okay.
Okay. Are there any more in that grouping 13 to 21 that you want us to try?
No. I sent you the word problems, I think, that are on the back.
Yes.
Okay.
Yes, we're going to get to those. I just want to look at like one or two solved by factoring, just so it's clear what to do. Yeah, and like 31's an example of one. Just make sure that you know what to do. Can you tell me in words, in your own words, what you now to solve this one?
Add 13x to both sides and then factor it
Okay.
out and then set both of my answers to 0 and then
Perfect. That's perfect. Yeah, good enough on that. Let's look at really quickly here. 27. Just again, tell me in your own words what you would solve this.
take the greatest common factor.
And that's X.
Yeah, and then set x to 0 and then set 3x minus 1 to 0.
Okay, very good. All right, so that's let's one more here. Problem like 26.
Okay.
What would you do to solve this?
Would that be just one answer? U2 set U2 minus 9 equal to 0.
So you kind of already answered this up here. What did you do? Why was this difference of squares? First of all,
Oh wait, because it's a square root. It's a
they're both squares. They're
yeah.
both squares.
So it would be u plus 3 times u minus 3, and then set both of those equal to 0.
Exactly. If you only get one answer, every quadratic has two solutions.
Unless it's like that perfect square one, and then it's really
It's
one answer, but
it's repeated.
it's
Yeah. Yeah. Okay. So just maybe as a mental note, like most of these need to have two answers when you're all done. Got it. Okay. Yeah. Let's look at these word problems. We'll just go through as many as we can here. In the time we've got left. I know the word problems feel scary in some ways, but you just have to get them down into something that you already know how to do.
yeah. So this one, it gives the area of the shaded region in terms of x. So
Yes.
so then it's a square in the middle, right?
Yes.
So, oh wait, there's two x's there. So wouldn't it be? So the area of, so you have to find the area of the light square, and
So
then,
I think of it as the big minus the small.
yeah, so you
Or
would
like you
find the
said,
area of the big one and then
yep,
subtract the area of the small one, right?
yes. So how do you find the area of the large one?
2x plus 3 times 3x plus 7.
And what do you subtract?
2x times 2x.
Okay. So this is correct. What I've just what you just told me is correct. I don't know if your instructor wants you to go further than this. Do you have any idea? Do you have an answer key?
I
Do
do
they-
have an answer key, yeah.
So what you want to look for in the answer key is, do they leave it like this, or do they
No, they
FOIL?
factored it all the way out. So
FOIL.
the
FOIL.
answer they got was 2x squared plus 23x plus 21.
Oh, yeah,
With,
right, right. So
yeah,
you need to FOIL this,
and then
multiply this.
subtract.
Exactly.
Yeah.
Okay. And so one of the reasons I was asking, like, do you think you'll get a problem just like this? Because there's like related problems where, like this leads to another problem, or, and I can always throw those at you, but I don't know yet. So I'll have a better idea in the future. Do you want us to FOIL this, or do you want us to just move on to another problem?
We can FOIL them.
Okay. Go ahead and work this one out then, and let me know if you have any questions.
2x plus 3 times 3x plus 7. FOIL that. And that's 6x squared plus 14x plus 9x plus 21, and 6x squared plus 23x plus 21, and all that minus 4x squared, 2x squared plus 23x plus 21.
Yeah, perfect. Really good.
Okay.
Okay. Let's go to 37.
Okay.
So
And
go ahead. Do you have a
so
question?
then for number 37, would it be easier if I draw like the door and then add the two sides, like to visualize it?
Yeah, most of what you said is perfect. Yes, you always want to draw a picture of some sort. It does not need to be very accurate. This is good enough for a door. The width is x minus 9.
Yep.
We do not know the height, though. We just know that the area, this
Oh,
is the area.
do I divide x squared minus 14x plus 45 by x minus 9?
Yes, but you don't know how to do that yet.
Yeah.
So there has to be another way. And the other way is x minus 9 times something equals x squared minus 14x plus 45.
So it's like reverse foiling it.
Yeah, I mean, you will know how to do this in a future chapter. Pay attention to the 9. How do you go from 9 to 45? How does
Multiply
that
by
work?
5.
Multiply by
-5.
negative 5. Yeah, and then x goes to x.
So x.
Yes, and then I would FOIL this and make sure that it actually equals what you want it to equal.
So then x squared minus 9x minus 5x plus 45. Yeah, it works.
It works. This is actually an SAT style question, not the whole door thing, but like figuring out the missing terms
Okay.
is kind of that. This problem could be given another way on the test where the teacher, basically tells you, something like this. They say, okay, it equals x squared.
Yeah, she did that on
Yeah,
the last formative, and you had to figure out what the missing term was.
right, right. And this is just a disguised version of that question. So
Okay.
if you understand that, great. Let's go to 38 here. You seem to really understand this stuff. I'm really curious what your tests look like, because I don't, I
I
don't know
have
why.
I can send you a picture of the quiz I took.
Let's get through these, and then if there's time, do that.
Okay.
And or you can just, or you can send it over at the end anyway, because I do want to see what it's like, because sometimes it's a mystery why students don't do, just as well in these lessons as they do in the test.
Yep.
All right, so the area of a square is represented by 4p squared minus 12p plus 9.
It's a perfect square trinomial.
Yeah, and it has to be.
So then
Because
it's
the
2p minus 3 squared.
minus 3.
Yeah.
And then 2p minus 3.
Yep.
Okay. Very good. So the question for you is, like, it says to give the length of each side in terms of p. Would your instructor give you full credit if this was all that you wrote for this problem?
I mean, I'd probably have to show work. So what I would usually do is show me doing the square root of 4p squared or the
Okay,
square root of 9.
you don't have to be more explicit and say like side 1 is 2p minus 3, side 2 is 2p minus 3. You
Oh,
have,
no, because she usually has it like formatted so that she'll give us like a length and it'll be like a line and then width and then it'll be like a line and you have to write what they are.
great. Yeah, always good to know that stuff in advance.
Yep.
All right, let's take a look at 39. 39 is a problem you will see in physics if you take that someday. But here it's kind of a simplified version of what you'll see. Foul ball leaves the end of a baseball bat and travels according to the formula h of t equals 64t minus 16 squared, where h is the height of the ball in feet and t is the time in seconds. Find the roots of the equation. So any idea what that word roots means?
Isn't it like the factors?
They're related, like factors lead to roots.
Okay.
Solutions, x-intercepts.
Oh, okay.
So
And then I noticed it was a
so the
perfect
factor,
square. Both of them were.
yeah, but it's not a perfect square trinomial. It has to have 3 terms.
Yeah, but they're just both perfect squares.
Yes, and that does help. So here, essentially, when you're finding roots, solutions, x-intercepts, you set equal to 0.
Yeah, it says when y equals 0. So
But there's no y in here, so you have to recognize that h of t is really
yeah,
y. Okay,
because
perfect.
isn't it like a function? So
It is.
anything like f of a or f of p is equal
Yes.
to y.
Yes. It's y equals h of t in this case.
Yeah.
Yes. Okay, very good. Now, what kind of factoring should you do here on the left?
Probably
What do you always try
greatest common
first?
factor.
Yes, yes. And you kind of said it already, but what is the greatest common factor?
I think it's 16. I think 16 goes into 64.
Anything else?
16t.
Yes, and it does go into 64. It ends up being 4 minus t.
T. Yep.
Okay.
Equals 0.
Can you solve this for me? Give me the 2 values of t.
T equals 0 and t equals t equals 4.
Okay, good. So graphically, here's what it looks like. 0 and 4, then
In
goes
the
up,
parabola.
it comes down, boom, hits there. Okay.
Okay.
So maybe in a future chapter here, you'll learn about how to find the max, but the roots, if it says to find the roots, the solutions, when it hits the ground, it could say when it hits the ground. That's the same thing.
Okay.
These all mean the same thing.
Okay.
Any questions on that?
Nope.
You might even see a problem like with a soccer ball in it. That's another common one. Okay. Oh, so 40 actually goes into kind of what I was just talking about. So that's a really good next problem for us to look at. All right, so if a toy rocket is launched vertically upward from ground level with an initial velocity of 128 feet per second, then its height h after t seconds is given by the equation h of t equals minus 16t squared plus 128t if air resistance is neglected. Find the roots.
So then set it equal to 0.
Yes. And I always like to have 0 on the right side. And so if you put 0 here on the left because that's what it says, I would immediately tell you to move it to the right side.
Okay.
That's just more you've done a lot of these problems.
Yeah.
So you got a factor, right? You don't have
I think 16 goes into 128.
so the rule for
Yeah.
16, there is a divisible rule for 16, but you could build a factor ladder. Well, you got a calculator, right?
Yeah.
Okay. So you got to remind me. It's like I don't want you to buy in. Yeah, see if it goes in.
It does. Yeah.
It does. Okay. Now you want to factor out negative 16t.
Okay, so then it'd be -8. So then -16t, -8.
What else? What is missing in here? What goes in here?
T.
Yeah, you seem a little uncertain. So whenever it just is another way to do it. You can divide each of these by the
Yeah.
GCF.
I was just making sure I put my t squared on the -16 and not the 128t.
Okay. Yeah, I mean it could be that vice versa. So what are the two solutions to this?
0 and 8.
Okay, so again, graphically, and then just call that, we'll assume that's 8, even though it's not to scale. What do the roots plural mean? So root 1, the first root is here at 0. They're asking you for like to write a sentence, like say what that means.
Yep.
Can you tell me in your own words what that means in the situation that's given?
So
And if you're not sure, maybe go to root 2.
yeah, so the initial velocity of 128 feet per second, and its
No,
height after.
yeah,
So
none of that's needed. None of that's needed.
I thought it was gonna be
Do you ever set off fireworks?
yes,
Okay. Do you hold them in your hand or do you put them on the ground?
you put them on the ground.
Yes. Well, you should. You should do that, right?
Okay.
That's what root 1 is. Root 1 means it starts
Oh, it started on the ground and then
on the
8
ground.
seconds later
It
it
landed
landed.
on. Yes, exactly.
Oh, because they're the x-intercepts. So think of it as like a plane, like where you're launching it from. If it
Exactly.
starts at 0, it
Yeah.
has to end somewhere.
Yes.
Okay.
Yes. And your teacher is looking for some words like that. They're looking for the word starts and the word ground, landed, hit, ground.
Okay.
They're not reading your full paragraph. They're looking for, did you hit those keywords?
Okay.
All right. So word problems are usually the hardest for most students. So I would recommend reviewing these, doing them again at a later time if you got some time before your test, summative. Why don't you pick some problems from the other side to work on that maybe you feel like are really challenging? And I just scan the page and be like, maybe I don't know how to do that one. Or I can pick some, or I can spend the next 5 minutes talking about primes.
What are primes? I don't really know.
Okay, so primes are not factorable.
Okay, so if you have a prime factor, the answer is going to be not factorable.
Yeah, so I'll give you an example in each case of a non-factorable situation.
Okay.
X squared minus 3y plus 4x. This is not factorable. There's no GCF.
Yeah.
Okay.
So you can't factor it according to the GCF?
Yes, or anything else, but I'm just sort of picking a GCF type problem.
So you can't factor x squared minus 3y plus 4x?
That's right.
Oh, because there's nothing that adds or that multiplies to 4x that
That's
adds
right.
up to -3y.
Yeah, and this could come in a lot of different flavors, but this is the one that I'm just picking. Okay.
Huh.
I'll try and do a better job for the other ones. GCF's hard because there's so many options. So the second one is difference of squares. So is 36 plus x squared, is that factorable? And the answer is no.
Yes.
No, it's prime.
Not?
It's prime. Difference of squares means you have to have a subtraction.
Oh, subtraction.
Yes.
So it can't be 6 plus x squared. Wait, why can't it be 6 plus x squared?
Like this?
So then you get 30. Oh, because then you get 36.
That's
36
fine. It's the
plus
12x.
12x. Yeah.
Okay, so here's another example. Let's say you get something like this. Solve, it'll say something like this: solve x squared equals -9.
don't you have to subtract the x squared to the other side?
Sure, we could do that. So -9 minus x squared equals 0. Now what are you
Yeah.
going to do?
Can't really do anything.
Like you could try factoring out a -1, but then it's 9 plus x squared.
Yeah, and there's still nowhere to go.
That's right. So this
And
is
you can't
another.
take the square root, right?
That's
Because
right. That's right. So these are examples of primes. These are like exceptions.
okay,
All right. So difference of squares. The difference means subtraction. If you don't see subtraction or you can't make it into subtraction, it's not difference of squares.
okay,
Next
and
one
that only
is,
applies if it's 2 digits, right?
yeah, if there's two terms,
Yeah, because if it's 3 terms, then it is factorable because
Sometimes,
then it's
sometimes. So, okay. So here's a perfect square trinomial that is not factorable. That's prime. All right. Let me just make some. So x squared plus 10x minus 25. Okay. So this is prime. Now,
oh yeah, because 5 times -5 times x doubled isn't 10x.
right. So sometimes sometimes, especially on the bigger ones, they'll do this where it's kind of deceptive. They'll do something like x squared plus 100. They'll go minus 10x like that. And the square root of x, go ahead.
Wouldn't that be x minus 10
It
squared?
would, it would, but why don't you FOIL it and tell me if it has to exactly equal this.
So x squared minus 10x minus, oh, there's a minus 10x.
So the problem is this isn't quite big enough.
Yeah.
So sometimes they're deceptive. I mean, that's why I don't know what your teacher's like, so I don't want to, assume anything, but these are two types you might see.
Okay, so if I see, so if I, so foiling for any problems that I'm unsure of answers for prime numbers is probably smart.
Possibly. I mean, it depends on the nature of your teacher. Like sometimes they really like to give you a lot of exceptions. Some don't.
Okay.
That's why I'm trying to be very cautious here about what to do, telling you to
Okay.
do. So in the an a equals 1 type, something like this, like x squared plus x plus 1. This is also prime. There's two numbers that multiply to 1 but add up to 1.
Okay.
Before you write prime, you should probably go down the test and work another problem and then come back and make
Yeah,
sure that,
yeah.
yeah. Okay, there are more, but this is probably a good place to sort of stop. So what's your plan to prepare for the rest of, what do you plan to do between now and the rest and your exam tomorrow? What do you plan to do to practice, if anything?